Hello everyone, this is Streamer and welcome to Genius Math Minds. In this video, we will be seeing a topic called Mathematical Induction. Now this is a really important thing when we are dealing with algebraic formulas, because we will study various algebraic formula and we will use it in various ways in our problems. But what this is, we can prove that algebraic formula that we have memorized. So this is like we have memorized something but we don't know how we got that. So this is like proving how we got that and why it works. So that's what mathematical induction is. Mathematical induction is just the way of proving that mathematical or algebraic formula. Like for example, we will be seeing a formula like 1 plus 2 plus up to plus n terms. This will be equal to n of n plus 1 by 2. This is a formula, but how did we get this formula? We don't know. But this formula can be proved by mathematical induction. So any like algebraic formula we can say that can be proved by mathematical induction. So that's what we are going to see today. So first, there are 3 steps to solve the mathematical induction. Any mathematical induction problem we will solve in 3 steps. So the first step is check for n equal to 1. So this is the first step. So whatever expression or whatever equation we get, we have to put 1 for the value and we need to check the inequality. Next, the second step is assume n equal to k is true. So the next step is you have to put the value of k. This is another variable. You have to put the value of k for n and you need to assume that it is true. So the third step is prove n equal to k plus 1 is true. So we need to prove this. So first we need to check if n equal to 1 is holding the equation. Next step is assume n equal to k is true. We need to assume this. The third is the actual proof. So prove n equal to k plus 1 is true. So these are the 3 steps. So n equal to 1, n equal to k, n equal to k plus 1. So these are the 3 steps. I will write these 3 steps here. So we have step 1 is n equal to 1, step 2 is n equal to k, step 3 is n equal to k plus 1. Here this is the actual proving step. The other 2 are like testing or the checking steps. So we'll use this mathematical induction to prove 1 plus 2 plus 3 plus up to n is equal to n of n plus 1 by 2. So this is the formula we have. We need to prove this using these 3 steps. So how we will prove that is, first we need to check, or first we need to denote like p of n is equal to this 1 plus 2 plus 3 plus up to plus n is equal to n of n plus 1 by 2. So this is what we have to do. So here p of n is like a function. So p of n gives 1 plus up to n term. So what this term actually means is, let's say we have p of 1. So instead of n we have to put p. So it goes from 1 to a natural number. So p of 1 is just 1. P of 2 is just 1 plus 2. And it goes on. So this is the actual meaning of 1 plus 2 plus up to n terms. So this is what the first step we need to do is, so just put p of n equal to that given term. So this is the first step. Again, this term is like n belongs to natural number. So this is a condition in this. So this expression or this formula works only when n is an integer. So that's a sub condition to this formula. So first we have done this. Now first step is put n equal to 1. So you have to put 1 equal to 1 in both these. So let's take p of 1 is equal to, so this term is 1. Next we need to substitute n equal to 1 in this. So n of n plus 1 by 2. So we have n 1 times 1 plus 1 by 2. So we can write as 1 times 2 by 2. 2 to cancel, which gives 1. So from this 1 plus 2 plus up to n terms, we have got 1 as the result. From this formula, we got 1 as the result. So this formula holds when n equal to 1. So that's the first step. That is the for checking if that formula even works for 1. So that's the meaning of that. So this step we have did. So first step is done. Next we need to put n equal to k. So p of k equal to 1 plus 2 plus 3 plus up to k terms is equal to k of k plus 1 by 2. This we no need to prove because this is the assuming step. So we have to assume that when n equal to k, it works for this equation. So when we put a value for k, it works. So that's what we are assuming. So the proving step is we have to put n equal to k plus 1. So p of k plus 1 is equal to, instead of n, we have to put k plus 1. So 1 plus 2 plus 3 plus up to k plus 1. So this is the value we have here. Instead of n, we have put k plus 1 in this equation. Now this n of n plus 1 by 2 also changes to k. Instead of n, we need to put k plus 1. Instead of n, we have to put k plus 1. In this formula, we have plus 1 by 2. So the final answer is k plus 1 times k plus 2 by 2. So this is the final answer of the right hand side. So we have found the right hand side answer. If we get the same value from the left hand side, then we can say this expression holds for any natural numbers for n. So that's what we have to get it. So the final answer for right hand side is k plus 1 times k plus 2 by 2. So this is what we look get. So if you see this equation, p of k plus 1 equal to 1 plus 2 plus up to k plus 1. Now what will be the predecessor value to k plus 1? Because we are getting from 1 plus 2 plus 3 plus 4 plus 5. We are going till k plus 1. So this we can write it as 1 plus 2 plus 3 plus k plus 1. Now why did this k come here? Because the predecessor of 2 is the predecessor of 3 is 3 minus 1, which is 2. The predecessor of 2 is 1, which is 2 minus 1. So the predecessor of k plus 1 is k. So we are getting from 1 plus 2 plus up to k plus 1. So this is what the meaning of this expression is. So here we have 1 plus 2 up to k. This we know is the value here because we have assumed p of k, that is 1 plus 2 plus 3 up to plus k, is true for n equal to k. So we can substitute the value of this since this equals this, we can substitute the value of this here. So that's the first step. So we are substituting the value that we assumed. So instead of this whole term, we can write this. So k of k plus 1 by 2. Here we have plus k plus 1. So this is the final term we have here. So in mathematical induction, that is the thing. We have to use the assuming term, or we will get an answer from this n equal to k that we are assuming. So we are getting an answer from here. We need to use that assumed term in this expression to prove this. So that is common for any mathematical induction proofs. So we have here. So we can take LCM and multiply this here. So we have k of k plus 1 plus 2 of k plus 1 by 2. Since we are cross multiplying. So that's what we have here. So next what we can do is multiply. K square, k times k is k square plus k plus 2k plus 2 by 2. Now this gives k square plus 3k plus 2 by 2. So this is the final answer we have here. But this is not the final answer we got from the right hand side of n equal to k plus 1. But these two are same. If we just factorize this, Or if we just multiply this, these two terms are literally the same. So if we factorize from here, we can write as k square plus k plus 2k plus 2. So we have k of k plus 1 plus 2 of k plus 1, which is literally this step. So we could have done that like that. Okay, we will just do from that step. So we are just taking common terms outside. So here k plus 1 is common. So we can take k plus 1 outside. The remaining terms are k from this expression and 2 from this expression by 2. So we have got literally the same answer, which means finally we have to write as by mathematical induction, P of n is true for n equal to k plus 1, which means the proof is done. So we can write hence proved. So this is how every mathematical induction proof works. So that's the thing with mathematical induction. The main thing or the algebraic thing in this mathematical induction would be to get this term, the assuming term that we have got is k of k plus 1 by 2. This was the term we got from n equal to k, the assuming step. We need to get somehow that term into this n equal to k plus 1 term here, like how we did for this sum. We got the 1 plus 2 plus up to k terms in this k plus 1 term. So that will be the step sum or the step thing we have to do to get this term here. So that's the proof for this expression. So the 3 steps in mathematical induction are put n equal to 1, put n equal to k, and put n equal to k plus 1. So this is about mathematical induction. Thank you.